Hello, today I will explain my answer for question 4, troubleshooting cloud services. In this scenario, University Student Portal cannot be deployed because the cloud application cannot reach the premises student record database. I treat this as a hybrid cloud troubleshooting problem. The issue may come from many places, such as the application connection stream, DNS resolution, cloud security group rules, route table, VPN tunnel, campus firewall, NAT rules, database listener, or database credentials. The key idea of my solution is not to guess the problem randomly. Instead, I use a step-by-step troubleshooting method from the cloud application to the on-premises database. Also, the troubleshooting process may not awaken security. The database should remain private, and we should not expose the database to the public internet just to fix the issue. Now I'll explain the diagram. On the left side of the diagram, I have the public access session. Student portal users access the platform through HTTPS TLS. The traffic first passes through the WEF and public firewall, then reaches the cloud load balancer. This part shows that the public users are only allowed to reach the web front end. They do not directly access to the database. In the middle of the diagram, I have the cloud student portal network. This one. This includes the cloud student portal application, the DNS resolver, the cloud security group or NACL, and the cloud route table. These components are the first major areas to investigate. The first thing I would check is the application configuration. The application may use the correct database hostname, database port, database name, database driver, TLS setting, timeout value, and credentials. If the connection string is wrong, the application will fail even if the network is working correctly. Next, I will check the DNS resolver. The database hostname must resolve to the correct private database IP, not at public IP. In the diagram, the database resolver connects to the cloud application with the database hostname lookup. If DNS gives the wrong IP address, then the application may send traffic to the wrong destination. To test this, I would use tools such as NSLookup or dig from the cloud application environment or from a diagnosed VM in the same subnet. After DNS, I would check the cloud security group or NACL. This component control whether the cloud application can send traffic to the on-premises database. For example, if the cloud database uses TCP 1433, 3306, or 5432, the security group should allow outbound traffic only from the cloud application subnet to the database IP and the database port. The route should not allow all ports or all destinations. Then I will check the cloud route table. I will zoom in. Yes. Then I will check the cloud route table. Then the route table must send traffic or the on-premises database CIDR to the cloud VPN gateway. If the route is missing, the traffic may be dropped or sent to the wrong next hop. In the next diagram, this is shown as the route to the on-PIEM CIDR. This is important because even if the application and DNS are correct, the traffic state cannot reach the campus network without correct route. Next, the traffic goes through the encrypted hybrid link session. This includes the cloud VPN gateway and the campus VPN gateway. The VPN tunnel must be up and correctly configured. I would check the VPN status, tunnel logs, encryption settings, PIB addresses, pre-share key or certificate, phase 1 and phase 2 setting, and traffic status. traffic sliders. If the VPN is down, the cloud application cannot reach the private campus database. On the right side of the diagram, I have the campus or on PREM database network. After the VPN, traffic reached the campus firewall and NAT routes. This is one of the most important troubleshooting points. The firewall must allow traffic from the approved cloud application subnet to the on-premises database and database private IP on the correct database port. It should not allow broad access, and it should not expose the database to the internet. The diagram shows that the database is inside the on-prem database subnet, and the on-prem student database is marked as private only. This means the database should not accept private database traffic from approved sources. If the firewall blocks the connection, the application will usually see a timeout. To prove this, it would run a test from the cloud application subnet and compare it to the campus firewall log at the same timestamp. The diagram also shows monitoring evidence. Log sent to the cloud. Monitoring a log. This is important because troubleshooting should be evidence-based. I will compare application error, DNS query log, Cloudflow logs, VPN logs, firewall logs, and database audit logs. For example, if the firewall log show a deny event at the same time as the application timeout, then the firewall is likely the root cause. If the database audit log shows failed login, then the network path works, but authentication is wrong. At the bottom of the diagram, there is the troubleshooting sequence. The sequence is very clear. First, check the application configuration, database host or port and credential. Second, check the DNS resolve. Check the DNS resolve. The private database name. Third, check the cloud subnet and security group rules. Fourth, check the route table to the VPN gateway. Fifth, check the VPN tunnel and IPsec policy. Sixth, check whether the campus firewall allows the application subnet. 7. Check the database listener port or authentication. Below that, the diagram also shows testing tool and exam phases. The two include ping or ICMP if allow telnet or netcat to test the database port, trace route or path test, SQL client connection test, and log comparison across the application, VPN, firewall, and database. The very important point is that ping allow is not enough. ICMP may be blocked, but the database port might still be open. So the best test is TCP port test and then a real SQL client test. For the test 2, I list several possible problems. I will show you in the document. This is my answer document for the question 4. Yes, these include wrong application connection stream, wrong private DNS record, block cloud security group, missing route to on-premises CIDR, VPN tunnel down, wrong VPN traffic sliders, campus firewall denier, incorrect NAT, database VLAN, ACL block, database lookup firewall block, stop database listener, wrong connection or database connection limit. The selected problems I choose for the detailed phasing is the campus firewall block traffic from the cloud application subnet to the on-premises database port. This is a realistic problem in hybrid cloud deployment because the database is private and the campus firewall normally denies and no sources by default. To prove this problem, I will create a one control test from the diagnosis VM or container in the same cloud subnet as the subnet portal application. I will run a TCP test to the database private IP and port. At the same time, the network administrator would check the campus firewall log for the same source IP, destination IP, port, and timestamps. If the application times out and the firewall show as a night event, then the root cause is confirmed. To secure phase is to add a less privileged firewall rule. The rule should allow only the cloud application subnet to connect to only the on-premises database private IP on only the required database port. Logging should be enabled and rule should be placed above the default deny rule. I would not open the database to the public internet, and I would not create a bot allow any rule. After the phases, I will verify it at 3 levels. First, at the network level, the TCP port tested should success. Second, at the database level, the SQL client should log in successfully using the application service account. Third, at the application level, the student portal should start correctly. Pass health check the complete database operation without connection errors. For the justification, this troubleshooting method is systematic, secure, and suitable for hybrid cloud deployment. It checks the application DNS, cloud network, route table, VPN, campus firewall, database listener, authentication, and logs. It fixes the problem without exposing the database publicly, and it preserves confidentiality, integrity, availability, and accountability. That is my references, and thank you.